Good morning, everyone. So we're going to talk through the Caliptra Firmware Stack. So I'll just give a quick introduction. John is so we work, all of us work on the Caliptra Firmware Stack. John is from AMD, and he is a security architect. Jordan is an engineer at Google who's contributing, a lot of features to Calyptra. And then myself, I'm from Microsoft, and we are all involved with Calyptra development. So we'll start with a little bit of an overview of what Calyptra is. It's a kind of a IP block that is a RISC-V core, crypto subsystem, and bunch of SOC interfaces for interfacing with the SoC. Obviously, there's ROM and mailboxes and other memories for code execution as well as data. So this was just a kind of hardware recap. So Caliptra firmware is broken down into 4 big pieces, right? One is the ROM that is immutable, that's in the metal layer. Obviously, the bundle has a header as well as the first mutable code and runtime. ROM loads the firmware, and it starts executing the FMC. Before we get into it, we should talk through some properties of the Calyptra hardware. There's a hardware key vault, and it's responsible for storing all the keys, as well as any cryptographic sensitive data like CDIs as well as HMACs. And the idea is the firmware never gets access to the secrets. So firmware can drive the engines, but never look at the keys. It's also we can manage the dice through the same key vaults, right? So each keys goes into different slots, like CDIs as well as the ECC keys for signing certificates. Right, so this kind of explains the firmware can access it via handles, but no access to the secrets directly. ROM overview. So the main goal of ROM is to establish the identity. It loads and measures the mutable firmware, and it's involved in all resets like cold, warm, or update resets. And part of the ROM, there's also an early command to store stash measurements from early boots from the SoC side. So while the ROM is booting, we can stash measurements if we had to. This is the traditional dice hierarchy. It kind of shows how we have rendered it in Calyptra. So there's a UDS that leads to a derivation of an IDEV ID. And there's a CSR that's used for provisioning device identity at the manufacturer end. And there's a LDEV ID that's mixed with the field entropy, so that provides personalization for for use cases in beyond the manufacturer's lifetime, as well as there is FMC alias keys that are generated and the certificates. So the ROM generates the keys as well as the certificate CSRs and the certificates that are needed for the subsequent phases. Firmware loading. So Calyptra by itself does not it's boot media independent. So it's the firmware is streamed from outside. So there's an SoC component that loads, pushes the firmware into mailbox. Calyptra ROM obviously validates the firmware, mutates the dice identity based on the firmware, and loads and executes the firmware. Right. So that is a high-level firmware loading mechanism. And other things we also have ability to extract the CSRs via the JTAG mailboxes. So they can be challenged by the manufacturer, send the CSR to the CA, get a certificate back into Calyptra. I'm going to hand over to John.
Yeah, thank you. All right, so I'm going to go over a little bit about the FMC. So that's the first mutable code that is executing within the Calyptra environment. It's a very thin layer of code, kind of following the DICE guidelines there. And so FMC is there for very specific security reasons. It's able to manage a few different key assets that ROM is given it, but it will not give to runtime, helping to isolate the identity to the right layer of privilege there. Also, the FMC is going to help us enable hitless updates. So I'll talk a little bit about that in this next slide. So FMC is an independent binary, completely separate from the runtime firmware that is executing. They're both signed together as the earlier image showed, but that independent binary allows it to be, allows the runtime firmware to possibly be updated on its own, whereas FMC could stay without an update to help us do the firmware update, the hitless firmware update. So FMC's main goals is to establish, to use that FMC alias key and to measure the host, and then to establish a runtime alias key, and then continue that DICE certificate chain. Now, obviously, for the FMC alias key, that one should only change if you ever update your FMC code, but runtime, if you update that, in theory, you could update that more often, and only need to ever update your FMC if there was any sort of real security concern that you would want to understand a difference and rotate your keys. All right, so and then the hitless update, one thing that we have in the key vault that Vishal described is that FMC is going to be able to leverage some of the keys that are derived by ROM, and they're locked and hidden in there from runtime, but only when FMC is executing is it able to use those keys. And that's to allow for, on a hitless update, not having to rederive everything, but still be able to get a fast update and still be able to derive new runtime keys. I wanted to quickly go over a little bit of some of the security reviews that we've done in Calyptra as a whole. So we've recently completed an NCC review. They've gone through our ROM and firmware and looked for any sort of attack vectors that could be a concern, and we've published those findings online. So there's a link to that, and it's within the GitHub repo. We've also done a lot of internal security reviews from the various companies, so Microsoft, AMD, NVIDIA, AMD. We've had a lot of security experts review the code, so it has been very important to us that we all know where certain concerns lie, and we want to ensure that the code that we're creating is as strong as possible. Lastly, we are also making FIPS, Calyptra FIPS certifiable, and CMVP for level 1. And what that means is that we're going through the overall process of making sure that all the FIPS interfaces are defined, that they're in there within Calyptra, so that it could be certified as a module. We are going to be releasing a security policy, which is a template security policy that could be used to guide various, any integrator in how to actually get their module certified. The key important point with the FIPS certification is to understand that it is a module that encompasses both your wrapper RTL as well as the Calyptra IP RTL. So the Calyptra IP is everything that you're seeing in the repo that we're delivering, and then to be able to integrate that into a system, you still need some RTL in your own system that would help provide services to Calyptra, a fuse box, a random number, noise source, and a few other things. And so the FIPS certification will be over all of that. And that's why it's not something that we can certify specifically within the Calyptra work group, but we're trying to do all the legwork possible to make sure that it's ready to go, and then an integrator could then take it to their lab, and it really wouldn't be as much work to be able to get it actually certified. So that's the completion of those, and we'll pass it to Jordan.
All right, thank you. All right, so we'll go back to kind of the additional firmware stages. So finally, we have runtime firmware. So that serves attestation APIs, which I'll get into in a second. It also handles runtime firmware updates. John mentioned that our runtime firmware is hitlessly updatable. So without taking down anything else on the SoC, we can update Calyptra runtime firmware. So we'll go over that as well. So you may recognize this wonderful diagram from Andres' talk, which we both stole from Jeff, so thank you, Jeff. So as Andres described, and hopefully my laptop doesn't die, As Andres described, we can build kind of a dice tree of various measurements throughout the SoC. So if you need to wield an identity for your confidential compute stack or for your SPDM responder, Calyptra holds on to all the keys for those. We don't have to, in a kind of a straightforward dice architecture, you may pass key material up through layers so that they have access to it later. As we mentioned, we hold all of that in the key manager, and then Calyptra exposes APIs for using those keys, generating dice layers, getting certificates over those measurements. Thank you, Jeff. And then the rest of the SoC using these services can just pass handles in and leverage the key material that's held inside of Calyptra. So the thing about this API is if you're over in Realm Manager, you have a view of the measurements that Calyptra holds for your specific context. But you don't necessarily have a view of all the measurements across the SoC. The goal of DPE is to provide an identity for the code that you're running, not the code that some other microcontroller on the SoC is running. So we also have this PCR attestation API. So Calyptra has a bank of hardware PCRs like you may be used to from TPM or we heard about in the SPDM 1.3 talk. So these measurements, or these PCRs hold both measurements for Calyptra's own firmware, as well as any measurements pushed in by the SoC. So as the SoC boots, it can extend into a bank of general purpose PCRs beyond the Calyptra firmware measurements, and then can ask for a quote over these PCRs so you can get a signed attestation of the whole SoC view if you want to ship those off to your PROT or just get a full view of the SoC in addition to the kind of identity stack that DPE provides. Okay, and then runtime firmware updates. So you heard Vishal earlier talk about that ROM kind of handles these different types of resets. We have cold reset, warm reset, and then update reset. So during an update, the SoC manager or something on the SoC that's going to manage the updates, so receive the updates and apply them, will load firmware into Calyptra's mailbox and execute an update reset. And then Calyptra resets back into ROM. ROM has special flows for doing updates. We reestablish the dice chain. FMC is still responsible for assigning a certificate for the new runtime alias key. And then we also maintain kind of that history of measurements in the PCR bank. So your whole SoC attestation still has a view of all the hitless updates you've gone through. And then just to close, I want to talk a little bit about kind of what our development flow looks like in Calyptra. So the Calyptra work group consists of people working on the spec, but also people working on firmware and hardware, and we all meet regularly. So I think that gives kind of a unique development flow where we can work on firmware features and then decide, hey, what if the RTL worked a little bit different this way? And we can give that feedback and have kind of a tighter feedback loop than I think many hardware projects tend to have. We can also get feedback from the RTL engineers. They can tell us, hey, we built this feature. How might you use it? How should we design it? So I think that's been really great to work together. I've also been much more empowered to dig into the hardware than I have on past projects. I can read the RTL. I can run it in Verilator. I can see how it all interacts. So I think that creates like a much more seamless development flow for hardware and firmware. And then I just wanted to give a quick shout out to Core's talk. Core and Vishal will give a talk later about our testing infrastructure and kind of our unified hardware model. So this is just a quick teaser. I won't really say much about this other than see it later today. All right, and then here's a quick slide of all the links that you may need to get in contact with Calyptra, contribute. We have a software repo, an RTL repo, and then kind of a main overarching repo with the spec. Has links to Slack, mailing list, all that kind of stuff. If you have questions about integrating Calyptra or just how it works in general. We have GitHub issues that most of the team monitors pretty regularly, so that's a good place to get in touch with us. I think that's all we have for today, so I'll open it up for questions.
Yep. Hi there, yes. Highly appreciate all your work over the years on this. Thank you. So I had to ask, thing that I did even ask in the Calyptra calls, weekly calls we have. So do you think that we can enhance the specifications document, say, with an application note that talks about how do we mitigate the TARA, the threat assessments and the threat matrices in the firmware and in the ROM? For example, like how do we use stack canaries, etc., to make it more robust to various kinds of threats, and then hence it could also act as a reference guide for other implementations.
Anyone? Oh.
So we do in the main spec, we do have a threat model in there that describes various threats that we're trying to address. If you feel that there was anything that was missing in that main spec that we need to be a bit more specific in, we could file issues, and we'll make sure that we get the spec completely updated with anything that we missed.
I was implying that if we point out, example, which facets are being handled and which APIs, example, certain checks being skipped over, so we could even showcase those APIs that here's an example how we're handling it. So the industry would certainly benefit a lot.
I'm not sure.
Thank you.
No, definitely, right? Like, we can do that. And it's like some of the stack canaries and stuff, right? Like, so the whole CFI business is like, is work in progress, and like, we need to make it better over time. So ideas, contributions, like, they're always welcome.
Thank you.
Apologies, I'm not a security expert, and my words may be poorly chosen. And so the question really boils down to, as an implementer evaluating Calyptra, we can obviously size the RTL, we can size the ROM. There was a reference in there that the first mutable code for Calyptra needed to be loaded from the SOC ROM code, which therefore becomes part of the size of the die area required to implement Calyptra. Is that a requirement, or can maybe the SOC's first mutable code be responsible for loading the first mutable code for Calyptra?
Yeah, that's a great question. So we added a measurement API into Calyptra's ROM. So the order of loading, whether you load Calyptra's firmware first or FMC firmware first, Calyptra is agnostic to that. So it's totally acceptable to, from SOC ROM, load your own first mutable code, measure it into Calyptra, continue booting, and then later boot Calyptra's own firmware. There are only 8 measurements in ROM. We're kind of constrained on resources, but that is a feature we provide.
That answers my question. Thank you.
Yeah.
Hey guys, question on the FIPS section. Just one clarification. Can we assume you guys are going to go through the CAVP validation for the cryptographic algorithms? Is that?
Yeah, it's CMVP, so it's the actual module, and I mean each of the individual algorithms in there will be certified that we're using both internally and anything that we're exposing externally. They would all have to be certified in that module.
Sorry, my question is, will you guys certify them, or is that part of our certification process?
It is going to have to be by the integrator. Anybody who's integrating it has to certify it. We're using somebody who does certify modules, that a lab that does actually certify modules, and so they're getting it all the way ready as far as we can get it. But because that wrapper has to be part of the module, there is no way for us to certify the IP that we've created.
Sorry, let me be clear. I understand your point. My point is about the cryptographic algorithms themselves, because there's a process you go through there.
Yeah, we don't intend to certify them specifically individually. We would expect that to be done by the CMVP portion.
Thank you.
Yep.
Hey, so question on the FMC. Does the FMC run only on resets, or does it run, is there flip-flopping between runtime firmware and FMC?
No, just on resets. Yeah.
Okay. And what are the FMC keys used for?
So it's just to derive the runtime keys, and so that if you ever did have a security bug that you want the keys to all rotate, then that's when you would update your FMC. So the FMC is really just a very thin layer that almost just runs and then jumps to runtime after it creates those keys.
Okay, thanks.
All right, any other questions? All right, thank you.